Okay, this is the second lecture that we have on optics. We talked about how light is an electromagnetic wave with the speed of light on the order of 3 times 10 to the 6, or 10 to the 8 meters per second. And now we want to talk about some behaviors of light. And really, optics is divided into both geometric, which you usually do with geometry and trig, ray tracing, etc., and then physical optics, which are things that depend on it being a wave. Geometric optics, it turns out, you can explain by doing either waves or particles. Newton and others thought that waves were particles, and he was able to explain all the things that we're going to talk about now. So let's talk a little bit about geometric optics. Remember, we said that light is a wave, but you can trace it like it's a ray. We think of a laser beam. The ray gives the direction of travel. The wave fronts are perpendicular to it. The two geometric effects we want to look at are reflection and refraction. So here's a nice demo. It's a picture of one that I set up in class often. You just take a laser beam and shine it on an acrylic or lucite. I think this one is block that's clear. If you do it just right, then you can see the incoming ray. So that would be our laser beam. We'll call that the incoming ray. And it gets divided. Some of it gets reflected, and some of it gets refracted. Reflected, refraction, and it's bent. You can see the angle's not the same anymore. Then it does the same thing off the bottom. And so that one is reflected internally, and that one's refracted out. So you can trace those. And that one's been done in a lab where you can set it up. You can see all of them. We don't usually get to see them all in the demonstration I do, and they don't really show up that well on camera. So reflection and refraction. Reflection is what you think of in a mirror. But there's really two types of reflection, and you've seen them both, though you may not have thought about it. And there's what we call specular reflection, which is what we just saw when the light beam bounces off a mirror. Really any surface, it doesn't have to be a mirror. That's what we call specular reflection, and the surface has to be relatively smooth. We think of a mirror. A mirror basically is a piece of glass with silver on the back, but it could be just a metal surface that's well polished. The other type is diffusive reflection, and that you've seen too. If you've ever seen a laser show, they put smoke, or what I usually do is put a little chalk dust in the air, and then you can see the beam. The reason you can see this beam is diffuse reflection. They've got small particles in the air, dust, and that bounces off. Now this is a rough surface. It's been, it's not polished, but it's rough, and so that's what causes diffuse reflection. Is all the rays don't go in the same direction. So that's when you see the sunbeams in the air, you're looking at light that's reflected off of dust particles usually. The specular reflection, we have a nice simple law that describes it. One of the things those who had Cal 3 might remember when we're talking about surfaces, it's very often useful to talk about the normal or perpendicular. A flat surface, it's easy, just 90 degrees, but even on a curved surface, we can define the perpendicular to that surface by talking about the tangent plane. And that turns out to be the best way to define the law of reflection, not the angle with respect to the surface, but with respect to the normal. Now, I've got a Canvas link that's in the homeworks too that you'll be able to go to, so let's go take a look at this one. And what it lets us do is it lets us vary the angle. So we'll call that the incoming angle, and that's the outgoing angle, and two things. They form a plane. The three lines, the incoming ray, the normal, and the reflected ray form a plane, and in that plane, the incoming angle and the outgoing angle are always equal. That's the law of reflection. Be a homework problem or two where they have you reflect off. Here's a situation where you're doing a mirror, so that you come in, it reflects, these two rays are equal. You know the angle with the mirror, 120, so you can work out what these two angles are, and then you draw the perpendicular, and then those two angles are equal, and that's called ray tracing. You trace the path through a combination of mirrors. All right, so I'll post some problems. We've worked out some reflections. That's the end of this video, our first video on geometric optics, and I'll do another one here on refraction.